All right, let's see some reminders about the course before we do some recap. Notes template, you know how to find them. They are on the lecture site. This Friday, there will be your programming test number 0 on the review materials. You should really study for lab 0, part 1, part 2, and also the required readings, which I mentioned in the first class, and also review lecture on classes and objects. I should be able to finish most of them. There might still be 1 or 2 more advanced examples, which I need to talk about on Thursday. But as I said in the e-class announcement, don't wait for me. You should really go ahead and study the review slides. I also make the static variable example code available already on the lecture site. Please take a look. And if that one there is not really included in your lab number 0, you should really play with it, just to see how that should work, right? It's part of the review. You should really make sure you understand everything in the review. And for programming test 0, the guide has been posted last week. You should really refer to the policy and requirements. And please make sure you only come to the section you are enrolled. Okay? Otherwise, you will not be, you'll be refused to actually take the test if you are in the wrong section. Okay? And then for practice test number 0, let me just make sure everybody knows where to find it. I posted, I believe, on Saturday, Sunday, anyway. If you go to the lecture site, you will see that under exercises, right? There's a practice test 0 here, instruction. So this PDF here is going to be more or less what you're going to see on Friday's test. And also for all the subsequent tests, you will find something very similar. I would just want to highlight something to you very quickly. Right, so there will be the programming requirements. Please read them. Make sure you're familiar. It's on the guide anyway. And also, I'll try to remind you guys every 15 to 20 minutes, just make sure you can submit your intermediate work so you don't really lose the work when the machines get rebooted. They will be rebooted promptly. And first link you want to pay attention to. Under the Get Started section here, there will be a link like here for you to download the starter code. So I kind of simulated for you. So if you click on that, it's actually going to allow you to download the starter projects, right? You can download it. I would suggest you try to open this document here in the remote lab or in a lab machine so you can completely simulate how the look and feel will be like on the lab machine, right? So that's the first link. You want to download the starter. And then another link I want to show to you, but some tips just about how you should really proceed with the test. But again, that's on the guide. Another link will be on the last page. That one there, number 1, is going to be about the name of the project you're supposed to export, the zip file, and make sure the name is right. And there will be a link right here, right? So that's actually for linking to the web submit. So once you link to it, make sure you don't really change anything there. Just browse for your zip file. Make sure you browse to the file you want to submit for grading. So guys, I would suggest practice this, right, before Friday. Just make sure you're familiar. You don't want to really waste any time during the actual test. So this document is already there for you, just for you to practice about the submission and exporting. And on Friday, before your test session, I will just ask everybody to please wait outside the lab. Me and my TA will set up the room and will let you know when you can come in. When you come in, please make sure you put all your personal belongings and your bag at the front in the desk. And then just get your water bottle, if you want to get your snack, and also your photo ID, right? That's the most important thing. We're going to need your ID. You do not need your mobile phone in the lab, in the test, okay? So that's about what you should really watch out for, at least for Friday. And then I also released lab number 1 on schedule since yesterday. That one there is not really covered in the coming test on Friday. However, I would suggest also get started with that as soon as you can. It's going to be the first lab that you might find a little bit more challenging. Maybe it's not exactly something you kind of practice back in the first year, but it's something you want to get used to for this course. You will be given a reasonable amount of JUnit test cases to start with, and you have to build everything from scratch, from the empty model cluster, and build everything in there. They'll require classes, they'll require methods, and that one can also help you for the next programming test 1, and etc. And the slides on classes and objects, I'm going to dive further into it. Again, don't wait for me. I'll try to get as thorough as possible in the class, but if for any topics that are not covered just yet, you're also supposed to study them. All right, it's covered on Friday. All right, any questions about the course? Awesome. All right, let's now do a very quick recap. So last time we actually talked about visualizing objects. That's something I will keep doing throughout the course. You got some name of the variable and some arrow, and also you got the box representing some type of objects with the attributes and also the attribute values. So this kind of convention here is going to lead us a long way as we try to solve different problems. I'm going to do it again today when we trace that exercise I gave to you about arrays and reference aliasing. We're going to do it together from scratch. That'll be on my agenda today. Second one. And we talk about how you can visualizing creating objects, right? By using a new keyword here, you can review them. That's going to be very beneficial. And once you have also talk about variable shadowing, right? We talk about them again. Okay, you can just review as well. I think this was some nice question posed by your fellow student. You can look at the discussion in the recording. And we talk about assert true versus assert false. So you really have to make it very clear in your mind. When we talk about assertions, there's only a matter of either pass or fail. It's nothing about true or false for assertion. However, when you talk about Boolean expression here, it's about evaluating some value at the runtime. It can either be true or false, but no pass or fail. But when you combine these two things together, you got to watch out, right? That's something I also discussed thoroughly last time, right? Take a look. It's actually not too bad. You just got to understand it systematically. And we talk about how you can trace OOP once you have created objects, how you can make some method call depending on what the context object is. We can step basically into the method call. That's also something we did. And I would encourage you to also try this kind of exercise both on the paper and also on the Eclipse using breakpoint and debugger, which you should really want to get both. And try to practice them as much as you can when you're developing your labs. So that'll be the best exercise for you to get prepared for subsequent programming tests. You want to practice as much as possible before the actual test. And that's about how you can use the accessor versus mutator. And you just have to know when it wouldn't compile and when it will compile. And there's also one scenario where you're calling some accessor, but you're not really using its return value. Such a waste. It will compile, but not very useful. All right, so you can also review the discussion we had last time. And then we talk about primitive versus reference values. So you just want to watch out for whenever you got, let's say, some P2 as a reference variable. When I say that one there, it will only store the address of another reference variable. That means we're copying the address around. So think about how we can visualize it. That's something we spoke about last time. And we're going to use this one very frequently today, especially when we get array into our context. So that was the last page we spoke about, which is just to trace this particular code here. This one here only involves the array and for loop. You can think about it's a nice review about if statements. There's no if statement. Maybe something about a primitive array and also for loop. And also, whenever you want to trace the for loop, always think about how many iterations you're going to run for the for loop. That's going to be the key. Once you know about how many iterations are going to go, you can kind of plan the layout for the loops. Iteration from iteration to iteration. For each iteration, how are you supposed to modify the variables accordingly? That'll be the way to go. And we're going to make this kind of pattern here slightly more complicated by considering reference variables as opposed to just primitive. That's something we'll do together today. Okay. Oh, so there's another one, which I'll start with first. So we talk about anonymous objects. So anonymous object simply means an object without a name. So if you look at here, so this is a new expression over here. So new expression itself tells you that somewhere in the memory is going to be allocated for this newly created objects. And then this one here is just the reference or address of the objects. But we don't really choose to store that somewhere like here in some variable. We don't do that. But this kind of expression here might allow you to write shorter lines of code, or maybe fewer lines of code. That's something I want to show to you. Okay, anonymous objects. All right, any question for last time? All right, so let's now first talk about anonymous object. I want to finish that topic quickly, and then we can move on. So these are the 3 lines that we spoke about last time, right? Let me just remind you, this pattern here about primitive array together with the integer counter are required for Friday, right? Remember there's a PDF there about point and point collector That's something you should really go thoroughly. And also for Lab 0 Part 2, I also talk about this pattern. You want to make sure you get proficient on this pattern here. It's also going to lead you a long way for this course. So right, we got these 3 lines. I will call this one here version 1 from last week. And then I'm going to develop further about this code. Think about this one here is version number 1. Okay, version 1. And in order for me to get to version 2, let's try to criticize this fragment of code. So I got version 1 here. I'm going to get 3 versions in total, right? All 3 versions will work the same way, but version 2 will be better than version 1. Also, version 3 will be better than version 2. Not in terms of the efficiency, but in terms of the coding style. Okay? You can choose either version as you feel comfortable, but I will recommend, I'll encourage you to always try to see if you can reach something like a version 3. Okay, let's see. Let's look at version 1. The first thing I would like to criticize is, you can see here, I got these 2 lines and these 2 lines. They kind of duplicates. They look basically the same. Whenever you're repeating fragment of code in the same class, we said that your code smiles. Sorry, not smile, smells. Is that a bad thing? You don't want to have duplicates. Okay? Not smiles, smells. Think about this guy here. And also this guy over here. They are basically the same fragment of code, but they are being duplicated. So whenever you got any duplicates, people say informally that your code smells. How do we improve it? The way to improve it is to really define the helper method. You will see one section in the review slide, also helper method. Since this coming Friday, you got your programming test, I'll see if I can do some in-lab demo maybe next Friday to show to you how the helper method will work in Eclipse. The way to do it is we just want to call a helper method. Since we already got add order over here that already defined these 2 lines, so we really don't have to write these 2 lines again. What we can do is we can simply call these 2 lines. Well, we can simply reuse these 2 lines by calling this method here as a helper method. That's what we can do. So number 1, you want to treat this as a helper method. So this one here can be used as a helper method. Okay, and that one there is just about adding some order, right? If you want to call that one there, so version number 2, we are just going to combine these 2 lines into a helper method call. Since the method we are calling is in the same class, so we can use this. And this really represents any context object we're calling, right? So you can say this dot add order. And since we're expecting some order objects, right? That's a parameter. Do we have an order object here? Yes, we do. NO, new order, right here. All right, so we don't really pass O, but we pass NO. So that's the object here that we can actually use, NO. So I'm just going to pass NO here. So that will be the first improvement we can do in order to arrive in version 2. So that one is version 2. All right. So think about when we go from version 1 to version 2, we basically just eliminate the smell from your code by using helper method. Helper method call. Okay, that's the first improvement. All right, the second improvement we can make, which will be related to anonymous object over here, right? You can see that the NO here that's being created is only used for being passed into this method call, nothing else. Because you can see the entirety of this method here is only about creating this object here and pass that into the method as arguments. There's nowhere else. Typically, if you're only using an object there only for one single place, that would be a very good candidate place for anonymous objects. So you don't really have to create some name for that. All right? So for version 2 to version 3, what we want to do is we want to somehow use anonymous objects. anonymous objects is going to be passed as arguments. All right. So for this one here, I'm actually going to look at this line here and also this line over here. I'm going to combine them into a single line. So that one there is going to be version number 3. So version number 3 here is going to be, I say this dot add order. So that will be the helper method call. And this part over here is going to be the arguments. But rather than NO, I'm just going to use the new expression right here. So that will be the anonymous object expression. So that one there is going to be, let me just use this one here. Okay, how about this one here? Just this one here. And for that one there, I'm just going to write it out. Okay, so that one there is going to be new order, and then the N and the P and the Q. And notice that N here is the N here, and the P here is the parameter here, and the Q here is the Q over here. All right? So that's version number 3. You can go for either version 1, where you got 1, 2, and 3 lines. Or you can go for version 2, in which case you got 1 line and 2 lines. Or you can go to the ultimate version number 3, where you only got a single line. All of them are correct. But version 3 will be something you will hope that eventually, once you get a little bit more comfortable with Java or OOP, you can arrive there. It's just so much simpler to write. Okay? All right, question about anonymous object here. Yeah, just practice that, and then you will see anonymous object happening quite often in the development of code. Right? That's something I'll leave to you. Okay. Yeah, take a look, and then of course, only understanding this on the paper would not be so much fun. I would suggest launch Eclipse, create an empty project there, and try to reproduce the code over there. Play with it, right? And then you actually explore more stuff that can inspire you about the programming. That will be something I'll leave to you. All right, the next one here is going to take us a little bit of time. I want to trace aliasing and arrays together with you. So for those of you who can grab a piece of paper or you want to open a blank page on your tablet computer, I would suggest you do it now to just get prepared. We're going to trace the code all together. So this exercise here is going to be very, very beneficial, especially for your written test. That's going to happen sometime in this semester. Especially there will be quite a bit of tracing question I'm going to put on the written test, and this will be one typical example you will see. Okay? We'll do together. I'll make sure I do that properly. Okay? So that one there is going to be on slide 52. Oh, just before I talk about slide 52, on slide 54. So this is about the point and point collector classes that I include as a required reading in the PDF, which I mentioned in the first class, right? So for these 2 slides, I'm not going to talk about it in the class because they are already assigned as a required reading. If you really want to somehow go over with me virtually, so this is the link over here, which I got some like a lecture recording from before. Very good quality. If you want to look at that, feel free. Or just drop by my office hour. I'm more than happy to go over with you. I would say this method here is something that you want to somehow expect to appear not just in the upcoming programming test 0, but in all the subsequent programming tests. That'll be kind of the combination of different programming structures that we kind of expect you to do. All right, one example. Okay, slide 54 and also slide 55, right? So these are the 2 things that are required readings, which are already signed since day 1. Okay, please take a look. All right, so now let's go to slide 52. Okay, let me just go there first. Slide 52. Okay, right here. And we're going to look at arrays and reference aliasing and see how we can trace them. Okay, first task for you. Take about 1 minute. Can you, first of all, please visualize about these 4 lines? So we got 4 object creations. And let's make the following assumption. Let's say the person class has 2 attributes that we care for now. Let's say we got a name, also we got an age. Name is a string, and age is an integer. How do you visualize these 4 lines? Start with them. At the same time, I'll do that on my iPad as well, and then I'll switch in just 1 minute. Okay? And you guys already know how to do object creation, tracing. When you do this kind of tracing here, just remember you got to be very faithful about each line. If that's about object creation, you draw the box, you draw the attributes, and put the attribute values accordingly. If that's about method call, you also got to remind yourself what the context object is. Okay, just one moment. I'm almost done, also myself. All right, let's take a look. There's one assumption which I forgot to mention. Okay, so here, when you actually look at, okay, let's now look at that. Okay, right here. Okay, so we got 4 objects here. Each one of them should be a box. So we got object 1, Alan, right here. Also, we got object number 2, Mark. Also, we got object number 3, and also object number 4. We got 4 different boxes. You can see each one of them is being pointed to by some name: Alan, Mark, Tom, and Jim. And the implicit assumption is the constructor over here, since we didn't take any argument about their age, let's say it will just be the default value, 0 for integer. So I got 0 here, 0 here, 0 here, and 0 here. Later on, there will be a mutator which will set the age for some objects, which we'll see. Right, so that's the first 4 lines. Everybody's good? All right. The next line. Let's say we have this line here. We have seen this last Thursday, right? Except it was actually for primitive type. Now we are basically doing the same pattern here for the array, but it's now reference type. Rather than storing integer values, we're storing addresses of person objects. So it's not too bad. What we're doing is we are trying to create an array that's called person1. Right? You can see it's an array of person objects. Every slot in the array, every index over there in the array is going to store the address of some objects. It's going to be the address that's stored in Alan, address that's stored in Mark, and the address that's stored in Tom. Right? And let me go a little bit further about explaining this line. Okay? So let's say for this line here, I'm just going to move it aside, but let me just box it right here. Okay, put a star here. Let me put it here. That single line here can be understood as 4 lines. We are going to create the array of size 1, 2, 3. And then we're going to set up the indices, index 0, index 1, index 2, separately. Okay, let's try to understand from that perspective. Think about index 0, index 1, and index 2. Okay? So what we do is we're going to get, first create the person array. Person P1 will be a new person array. And we know that we should really create an array of size 3. What that will do is it's actually going to, person's 1, let me just say P1. For short. P1 over there is actually going to point to an array of size 3. Okay? So indices 0, 1, and 2. Right? In this alternative version over here, I'm just creating the array first. Every slot in the array initially is going to point to just null. No address has been stored just yet. Right? Every one of them is just going to be null in the beginning. Null, and also null. And then how do we understand about Alan here, Mark here, and Tom here, right? So think about them as separate variable assignments, which we also learned about last time. So here, for index 0, so P1 at index 0 is assigned to Alan. Also, P1 at index 1 is assigned to Mark. Okay, let me make some space for myself. One moment. This will be, sorry. There we go. Okay, that should be good. Okay, and the third one will be P1 at index 2 should be Tom. So think about these 4 lines are what's happening behind the scene for making this one line work. All right? Now, how do we visualize this one here? P1 at index 0 is now going to, rather than storing now, is going to store whatever that's stored in Allen. Allen visually is pointing to this object here. So the way to trace it is, this slot here is also going to point to Allen afterwards. Right? So that one there is going to be the first one. So rather than pointing to now, it's now going to point to wherever Allen is pointing to. And we spoke about this, right, last time, just not in the context of the array. And P1 at index 1, which is right here, and rather than pointing to now, it's going to point to wherever Mark is pointing to, which is going to be right here. And P1 at index 2 is going to, rather than pointing to now, it's going to point to wherever Tom is pointing to. You know what? Let me just cross the line here. That would be better. Okay? And I can definitely try to do that. There we go. So after this single line here, that's what we have. We have the first array, persons 1, that points to Alan, Mark, and Tom. Right? Question? And we're going to create another array called persons 2. Okay, let's now execute this line. That one there, let me now use orange. This line here is just going to create a persons 2 array, and every slot is going to be just null. And in the for loop that follows it, it's going to assign slot by slot, which we'll see in one moment. And what should be the size of persons 2? Persons 1. That means we're creating some array that's equally long as persons 1. Persons 1, P1.length, as you can see, 1, 2, 3. Should be 3, right? So persons 1.length is going to be 3. So what we'll do is we're going to create this array, P2. Okay? So P2 is going to point to another new array equally long. Okay? So index 0, index 1, index 2. Okay, just give me one moment. So index 0, index 1, index 2. In the beginning, all the slot is just going to point to null in the beginning. Right? So you can think about what we're doing here. It's pretty much like how we did it as a first step for P1. But just that for P1, you have to assign to Alan, Mark, and Tom, right, as part of the expression. And now we're going to trace the loop right here to see how that is going to somehow modify the contents for persons 2. Let's now do it. This line here and this line here. It's a for loop. And as I mentioned, whenever you want to trace a for loop, you definitely want to start by thinking to yourself, how many iterations do I have for this for loop? And it really depends on the initial value for the loop counter and what's the upper bound for the counter, and also how the loop counter is going to modify itself, right? All these factors. So persons 1.length, we know that it's actually 3. So we start with the loop counter 0. It must be all the values strictly less than 3, right? And then it's going to be incremented by 1 each time. So we got 0, 1, and 2. So these are the 3 values. Okay? So to really trace this one here, I'm going to put it aside, right? Let me say star, star. Right here, right? So we got 3 different iterations. We got iteration number 1, where I is simply equal to 0. Iteration number 2, I will be incremented from 0 to 1. And iteration number 3, I is going to be incremented from 1 to 2. Would it be iteration number 4? Not really, because once it's incremented to 3, 3 less than 3 is going to be false. So no further iteration, right? That's kind of the logical thinking you want to have in your mind, right? There could be more. Yeah, and sorry about the cutoff a bit, in the projector. But if you look at the recording later, it's going to be fine. There might be something I can do here. How about that? Okay, slightly better. Right, so let's now think about each iteration. For each iteration, we are basically saying persons 2 as some index indicated by the loop counter value, which can be 0, 1, or 2. And then accordingly, we're going to copy the address that is stored in persons 1. The index, again, is going to depend on the current value for the loop counter, which can be 0, 1, or 2. And for completeness, let's now write it out. For iteration number 1, we're going to have P2 at index I, which will be 0, right? You can see I is 0. It's assigned to P1 at index 0. You can see in the counter, in the pattern here, I, 0, 0, 0, right? Accordingly, I will do the tracing in just one moment. Let's write them out. The second iteration, again, P2 something will be P1 something. But now in this case, we got 1 here. So 1 here and 1 here. And for iteration number 3, P2 as something, the loop counter value, and P1 counter value is 2. So 2 and 2. Right? Pretty systematic, right? And what we should do now is to really trace by modifying the diagram. So this is the very important point. If you got this step wrong, the consequence will be you cannot trace properly afterwards. Okay? Let's now do one by one. What about this line here? P2, 0 is right here. And then it's going to copy the address that's stored in P1, 0. Right? It's right here. Diagrammatically, afterwards, P2, rather than pointing to here, is going to point to wherever P1, 0 is pointing to, basically. Right? So that one there is now, rather than pointing to now, is going to point to right here. And then the second iteration here, P2 at index 1 is right here, is going to copy the address from P1, 1, right here. P1, 1 is pointing to this object here. So that means after the assignments, P2, 1 is just going to point to the same object here, right? Think about after this line here, P2, 1 is going to point to wherever P1, 1 is pointing to, right? The same object, okay? The final line, the final iteration. So P2, 2 is right here, and P1, 2 is right here, right? So rather than pointing to now, it's going to point to the same object right here. Right? So those are the 3 iterations. Okay? Okay, so let's now try to trace further because we wouldn't get into any question for you like a system that other print line until we have traced another one. Right? Next one. Question? Just give me, yeah, sure. Go ahead.
For the arrays for P1 and P2, does it store the variable reference or does it store the actual address?
So P1 and P2, right? So persons 1 and persons 2, they are array variable. They are like a reference variable, yes. So you can think about persons 1, P1 simply store the beginning address of the array. That's how you should understand it. Diagrammatically, so P1 will just point to the beginning of the array.
Yeah, for the first index, like for P1, does it have the actual address or does it?
Yes. So when,
does it have address?
yes. So when you say P1, for example, P1 0, you're basically saying now P1 refers to the beginning of the array, and I want to go to index 0, which is right here. And index 0 here store the address of some person objects. So that's why we kind of have this pointer right here. Right? Okay. All right. How do we change this line here? So we are calling the setH method. What's the context objects? Context object is persons 1 at index 0. All right. So what you really want to look at, I'll make it a little bit larger for you. We are making a method called setH. But it is important for you to know what the context object is. So think about this is the context object. It's context objects. So what you got to do is you got to go to that particular object, which will be persons 1, P1 at index 0, which is pointing to this object here, Alan. And then we're going to modify its age to be 70. So what we do is we're going to change from 0 to 70. All right? So figuring out what the context object is very, very important. Okay? After this, let's now answer some question. What will be easy one? Jim.getAge, 0, right? Easy. What about Alan.getAge? 70. Thank you. Okay. You see, once you have a trace that properly, it's very straightforward. But the critical thing is, how can you trace that properly, right? You got to practice. All right. So that one is 70. And without I tell you just yet, what will this be? Persons to 0.getAge. 70. Okay. Persons to index 0 pointing to this object here, which happened to be Alan. So 70. Okay. All right. All good so far. And let's make it a little bit even more complicated. Let's now talk about, let's say, another 2 lines. Let's say I got this line here, and also this line here. These 2. Okay? The first one. When I say this assignment here, I'm saying that persons 1 at index 0, I'm going to reassign that into whatever Jim is storing right now. Jim is storing this object here. So that means now persons 1 at index 0, let me just say it again. Persons 1 at index 0 is pointing to here right now. After this assignment, it's going to point to wherever Jim is pointing to. Right? That's what you would do. All right? So let's do that. Rather than pointing to over here, it's actually going to point to wherever Jim is pointing to. Okay? So this is the star over there. All right? Every time you got variable assignment here where we talk about reference type, you're basically just copying addresses around. And whenever you're trying to copy address, the way to visualize it is change the arrow around. Okay. And what about this one here? Okay, so for this one here, we got person 0 dot set age, 75. Guys, what's person 0 now? Jim, exactly, right? Now we're going to set the age to be 75. All right. So this one here, let me say star over here. And this is the context object, of course. That one there, 75. So star right here. All right, so let's now try to get a question done. And then I'll talk about one more thing, and then we'll take a short break. Okay. Jim.getAge, 75. Okay. Alan.getAge, 70. All right, you can look at the diagram. What about persons to 0.getAge? 70, right? Persons 2, index 0, pointing to here, 70. All right? That's a complete tracing. I would suggest, if you really kind of understand what's going on, great. After the class today, print off this blank page, do it right away. Make sure you can do it. Okay? Yeah, I'll leave that to you. I want to talk about 2 things quickly, and then we'll take a short break. The first thing is about how you can copy the array in a slightly higher level, if you want to copy the entire array. So what do I mean? So this one here, let me say reassigning array references. Okay, so what do I mean? Illustrate to you. Let's say we got 2 persons array. We got P1 and P2, let's say. Let's say PS1, PS2. So we got person array over here, let's say PS1, which will be some new array. Let's say whatever it is. What can be the curly brackets notation, whichever way you like, right? Let's say we kind of create that first. And we got another person's array over here. Let's call it PS2. New something, all right? Let's visualize what has happened so far. So that means we got PS1 is an array, a variable pointing to the beginning of some array, let's say, of some length. That's good enough for visualization. And the second one there is PS2, because we're using a different new expression, so it's a different array. Just an array here. Could be just different array objects. And let's now try to do the following. Let's say I want to somehow copy over the contents of the array. The easiest way for you to do it would be, let's say this. Let's say I want to copy everything over from P2 into P1, let's say. So this will be the easiest way I can do it. I can simply say P1 is assigned to P2. What is this line doing? Let's write it down. Copy the address stored in P2 into P1. So what I would do is PS2, oh, I should really say PS1, PS2. Yeah, let me be consistent. Okay, let me do it again. PS1 and PS2. And PS1, PS2. PS1, PS2. All right, let's say that's what I have. What I would do is PS1, rather than pointing to here, is now going to point to PS2. Okay? Let's now try to do some checks. This is something I want you guys to also give a try. Okay? So let me do the following. Okay? So think about like this. Right after these two lines, let's say right after these two lines, I got number 1 here. And then right after this one over here, I got number 2. Okay, we got 2 different timings. The first timing here is right after I created 2 separate arrays. And number 2 over here is right after I do the variable assignment. Okay, I got 2 different timings. And I want to check the same 3 Boolean variables. Let me write it down. The first one is P1 equals null. The second one is P2 equals null. And also P1 equals P2. Okay, let's now try to compare these. Of course, we're not only doing this exercise here on paper, you should really try them out also on Eclipse just to convince yourself. And let's now talk about different timings over here. What about at timing number 1, right after creating PS1 and PS2? Again, when I say P1 here, I really meant PS1. Okay, let me be very, very precise. Otherwise, it could be confusing. So I got PS1 and PS2 and PS1 equals PS2. All right. Right after this, right here, PS1 equals null, true or false? False, because it's really pointing to something after the new keyword. PS2 equals null, false. PS1 equals PS2, false, because they point to different array objects. All right, right here, after these 2 lines. So it's going to be false, false, and false. What about timing number 2? Timing number 2 is after we have done some reassignments. PS1 is going to copy whatever PS2 is storing. So PS1, rather than pointing to here, is now going to point to right here. That's timing number 2. And for timing number 2, let's try to evaluate the same 3 expressions again. PS1 equals null, false, because it's pointing to something that's not null. PS2 equals null, false. PS1 equals PS2, true, Good. All right? False, false, but now it's true. All right? One more. Let's say I want to do another line. Given that PS1 and PS2 are pointing to the same array, if I try to modify something to PS2 in some particular way, is it going to modify PS1? That's my question. But let's see what the change is. Let's say I'm going to do one more line here. I would say PS2 equals null. After this, I would say that's timing number 3. How do I visualize this? PS2 is assigned to null. That means this reference here is not going to store the beginning address of this array anymore. So that means here, I'm just going to say, rather than pointing to here, it's just going to point to null. Is it going to impact PS1 at the same time? No. That's the main thing. All right? So now we got PS1, PS2 in the updates. So let's evaluate this once more. PS1 equals null. False. Thank you. And what about PS2 equals null? True, because it does point to null right now, because of timing 3. What about PS1 equals PS2? False. You can think of one is pointing to something that's not null, the other one is pointing to something that's null. Of course, they are not the same. All right, just to give you a little bit more example about how array references can be reassigned. Okay, just one more. About reference aliasing. So this is basically just a little bit of the simplified version of the example we just traced a few minutes ago. I just want to talk about aliasing very quickly and give you just a little bit more example. Aliasing is really about multiple variables storing the same address. That's really how you should understand it. This one here is really about multiple variables storing the same address. Okay, that's the definition. Or you can think about multiple variables pointing to the same objects, same idea. And I just want to give you the following question here. Let's say we got the object here called Alan or Mark. Oh, here, let me change the question here. I think having Mark would be more interesting, if you don't mind. Okay, so let's identify the Mark objects right here. Right, you can see there's an object with the name Mark right here. Do we have reference aliasing here? We do. Now the follow-up question is, if you think there's reference aliasing, that means there are more than one variable pointing to the same object. How many variables exactly? How many expressions can you actually write to represent the same address? How many? The diagram itself actually gives you some very, very explicit hints. For example, Mark is pointing to here. You can see the arrow here, right? Basically, to really figure out how many, look at how many arrows are pointing to this object here. I got 1, 2, and 3. That's the first question. We got 3 variables storing the same address. That's the first question. 3 variables storing the address of the Mark objects. That's the first question. Second question is, which are the 3? Right? We got to write them out. The easy one will be just this. The Mark right here, right? So that one there, I can just say just Mark. And what about second one? Second one will be, for example, here. That will be from index 1 of the persons 1 array. So how do we write it out? So we can say persons 1 at index 1. And the third one will be right here. It will be index 1 from the persons 2 array. So that'll be the persons 2 array at index 1. So these are the 3 variables storing the same address of the objects that has Mark. All right, just another kind of example to show to you reference aliasing, which you will have to encounter just in OOP unavoidably, very often. Okay. Keep this in mind because you will definitely need that quite a lot, especially when we get to lab number 1, 2, and 3, and so on. You will actually have to trace the code, sometimes on the paper, before you can know how to debug about a different scenario. Right? So that's something you have to keep in mind. All right, any questions? Right, why don't we take a very short break by taking attendance, and after the break, I want to talk about static variables. Okay, let's take a short break. And get your iClicker ready, please. Okay, we got about 25 minutes. I think maybe a static variable will be the last topic I can talk about today, which is not bad. Okay, let me just try to finish that. So that would be on slide number 75. Okay, so I would suggest you definitely want to study that one. For sure. Okay, static variables, slide number 75. Okay. So before we talk about static variable, how exactly it works programmatically, let's look at some motivating scenario. Why the static variable could be useful. Let's say we don't have static variable, how things might work for this kind of scenario. Okay. Let's say we have a class called account. Let's say bank account, maybe user account for Gmail or whatever account, right? Just in general. I'll go over this class together with you, but can you please just take a look at this class just by yourself? Just take a 30 seconds or so, just to see how the account class is supposed to work. And then we'll discuss that. Especially, I want you to pay attention to the parameters for the constructor for the account. Pay attention to, number 1, how many parameters there are, and number 2, what are they? And what are they supposed to do? That's something I want you to pay attention to. All right, let's now take a look. Okay, for now, you can just disregard, just for now. Okay, let's focus on this class only. So we have our account class. We got 2 attributes. We got ID and we got owner. Of course, if you want to visualize the account objects, you're going to have 2 rows, ID and the owner, integer and string. And we can get an ID, straightforward, but I want you to look at this account constructor here. That's important, okay? So the same name as the class, and then it's straightforward to get owner, and also ID and ID. But I want to pay special attention to the ID. This one kind of tells you that in order to set the ID of the account, you can think about ID is really some unique number that we use to identify each account. For example, let's say your social insurance number. No 2 persons should really have the same social insurance number. They are more like an ID, right? It's really to use to uniquely identify some entity, in the real world. Okay, so let's now do some comments over here, and then we'll talk about some test cases. So you can think about the ID here. We put that as an explicit parameter. So this is an explicit parameter. Presumably, the ID that we pass over here should be like a unique number that we haven't used before. Every time you're trying to create a new account object, you should really give an ID that has not been used before. Otherwise, you are creating 2 account objects with the same ID, which is not what we want. Presumably, not duplicated. All right, let's now look at some example. Of course, you can feel free to turn them into JUnit test cases if you want to, but let's just use some console application just to illustrate the point quickly. So here we got ACC1, ACC2. I'm trying to create 2 account objects, right? We don't even need to visualize it. You can see that here. I pass 1 and 2 here just for the ID here. So for me, as a user of the account class over here, I have the burden to make sure the number argument I pass over here are unique. I don't really repeat myself about the ID, okay? So the comments to put over here is the burden is on the user. So burden on the account user to specify unique ID. Meaning that I should really somehow keep track separately about what numbers I have used so far for the ID. Right? The next time, if I want to create a third object, I cannot reuse 1 and 2 anymore. Right? But here's the problem. Oh, sorry, before that, you can simply say acc.id, acc2.id, they should be different. That's what we want. However, is Java compiler going to complain if I did the following? I simply say, rather than giving 2, I will just give 1. Obviously, that's an error because I'm repeating the ID for the 2 different account objects. But am I going to get any compilation error? Not really, because 1 here, argument is matching the integer parameter. 1 here, integer argument is also matching the integer parameter. Nothing wrong. But there's a huge logical error right here that we want to make sure we don't really have. Right? So that's why point number 2, which is more important. So point number 1 here and point number 2, when IDs are duplicated, it's not a compilation error. Meaning that you will only be able to find out such error at the runtime when you start executing your program. All right? That's not good. So that's kind of the motivating scenario here. We want to somehow make sure we have a unique ID for all the accounts. But at the same time, we should never, ever rely something that's manual to really give us the unique ID every time. We want to have a way to maybe automatically generate unique ID behind the scene so we can use it right away. Anything that you can automate, you should really let it be automated. Okay? So this is what we want. So our goal for this part of the lecture is we want to have some auto ID generation and management. And management. That's something we want to achieve. And what can we use to achieve this? Static variables. But here's the thing. As soon as we introduce the keyword static into the context, you want to be very clear about when to use static and when to use non-static. If you're going to somehow get mixed up, that's also going to be problematic. Right? So every time you got some tool, you got to make sure you use it properly and only when necessary. Before I talk about how to solve this problem here using static, let's look at some example. Okay? So that example there can also be downloaded from your lecture site. That's something I also made available to you. Right? Let's look at how the static variable can be understood visually versus non-static. Right? So these two should be discussed side by side. Okay? So let's say we got 2 classes over here. So we got the counter class, we got a counter tester. Again, you can feel free to turn them into JUnit tests if you want to, but for quick illustration in class, let me just use console tester. Okay. So we got counter here, right? And you want to see right away, right here. We got integer, L and G. L standing for local, G standing for global, right? Just make it more explicit. And you can see this one here, we got static keyword. But this one, we don't have static keyword, right? You can see right away syntactically. Okay? So let's now try to understand them syntactically and see some basic definition. So we got integer L right here. And also we got static integer G, right? So these two. Just by looking at the syntax, we can define them. Okay? So let me now do the following. So this one here tells me that it is a non-static variable. Non-static variable, or we just call them attributes. On the other hand, when you actually got a static keyword over here, it's a static variable. Static variable. Or you can say it's a global variable. We'll understand a little bit more visually what exactly global really means. We'll get there. Okay? So we got static, we got non-static. Okay? And then let's now talk about each one of them. Just give a little bit more information. For non-static, we know very, very thoroughly from our review material so far, non-static simply means each instance or object of the counter has its own copy. Okay? Each counter instance or objects has its own copy. And we call it the instance-specific value. Right? That's something we also said earlier. So that would be the instance-specific value. On the other hand, if you declare some variable as static, that means it's kind of global. It will be global across all the instances rather than just within a particular instance. So there'll be only a single copy rather than separate copies. Okay? So that one there, I'm going to put star, star. Okay. All instances, all counter instances or objects share the same copy. Share the same copy. Okay, it's global. So when we visualize these two variables later, you will see there will be multiple values between different objects about L. But there will be only a single copy of G. Okay, that's something we'll see a little bit later. Okay, a little bit more. Here, let's see this. Let's see one more thing. You can see when we have integer L over here, right? That one there, we don't really initialize it. Usually we only initialize the non-static variable or attribute in the constructor. That's what we normally do. Okay? So for that one there, initialize attributes in constructors. For example, you can see this.L equals 0. Normally, even though it's not really an error, you can say L will be just assigned to 0, but that's not the normal practice. On the other hand, for the global variable here, you can see we got initialization right away. All right? Because it's not really somehow depending on creating new objects. You can actually have some value right away. So for that one there, you can think about this one here. Okay, equals 0, right? Just for this part here. Okay, just for this part. So that one there. You can initialize it right away. So that will have the 0 value right away. Okay, we're going to trace it in a moment. All right, let's look at the methods in the same class. So we got constructor here. You can see in the constructor, we only initialize L, but we don't initialize G. It has been initialized already, so we don't do that. Also, we got get local value. We get increment local, right? Just accessor, mutator. And now increment global is interesting here. Okay? We simply say G++. Okay? So there are different ways you can write this. Okay? You can also say this dot G++. However, if you try this in Eclipse, it's going to give you like a warning. Because normally when you refer to some variable that's declared as static, it's really meant to be used at a class level, not at the instance level. So when you really do this some static variable, it's not really wrong. It's just that there might be some confusion from your understanding. The Eclipse is suggesting to you. Okay? For this one here, you will get some warning. The correct way to write this would be, you want to say here. Counter, which is the class name, dot G, and then plus plus. This will be recommended. Okay, I'll give you a rule. Every time you actually want to refer to some static variable, this will be the rule. You want to say something dot something. And then to the left of the dot, it should be a class name, like a counter. And the right-hand side should be the name of the static variable. The name of static variable. For example, you can see the name of the class is counter, and the name of the static variable is G, right here, right? So that's something you want to also pay attention to. All right, so let's now try to visualize what's happening here when we actually try to kind of use these two variables. So once we understand the distinction between them, we can now go back to the account example and see how we can trace them. All right, let's do them one by one. Let's now, first of all, create C1. Okay, C1 over here is going to be one object here, right? So that one there, we know pretty well how to visualize it. So we got C1 pointing to some counter objects right here. Okay, counter. And according to our convention, we should really put all the attributes over here. In this case, we do not include static. We don't really consider static variable as like attributes. We don't. So only the local. All right? So you can see C1 has its own copy of L. And the constructor is going to initialize it to be 0. What about the global here? So you can think about this one here is already initialized to be 0. You can set it aside. Okay? So the way I'm going to visualize it is like this. I'm going to set it aside over here. And again, to really avoid confusion, I will still put a class name here. Okay? So this is going to be all the global variables for the counter class. But here, I'm just going to say G. But maybe I'll put a star over here. Star simply tells you that that one is global. It's not like attributes. Okay? And that one there would be initialized to be 0. Think about even before C1 was created, this global variable is already there because we got initialized to be 0 right away, even before the constructor is called. Okay? So we got a global variable, G, and we got C1.L, right? And let's create the second objects. The second object will be C2, right? So I got C2 over here pointing to another counter object here. That one has a separate copy of L. And of course, it's also going to be initialized to be 0. So now you can see what I really meant by what I said earlier. Each counter object has its own copy of the non-static variable. Copy here and copy here. However, there's only a single copy for G that's static. And then let's now just answer some question here quickly. C1.getLocal will be 0. Okay? And also, C2.getLocal is going to be this one here. All right? And then what about we try to access the global variable? So there are different ways you can write it. If you try C1.g, C2.g, and versus counter.g, these two are fine, but it kind of suggests some confusion. Whenever you want to refer to global variable that's static, you should really try what I said earlier about the rule over here. You should really use a class name. But all of them is just going to give you the value here, 0. 0, 0, and 0. But this one here is more recommended. Whereas, if you try these two, they're going to give you warnings. Not errors, but warnings in Eclipse. Right, let's now do something to modify these variables to see how things will go. Okay, I'm going to number the lines here. Let's say we got 1 here, 2 here, 3 here, and 4 here. Let's do very carefully. What about number 1? Number one, we're gonna say call the method increment local. Increment local is right here. And the context object here is C1. And this will be replaced by C1. C1.L plus plus. C1.L plus plus. So this is what one will do. Right? What about number two? For number two, let's see here. For number two here, we're calling the same increment local method, but now the context object C2. Replace this by C2. C2.L, C2.L, incremented from 0 to 1. So that's what's being done by number two. Right? Different copies, even though they will end up being the same value, but just different copies. And then how do we increment the global? C1.increment global, C2.increment global, basically we're calling this method here. Right? So C1.increment global, we are just going to increment the G just by 1. All right? So let's see. So this will be number 3, and we are just modifying the global copy here from 0 to 1. So this is number 3. And finally, we are going to say C2.increment global. We're calling this again G++. So from 1 to 2. That one there is number 4. Right? So these are the steps you want to be very clear about. And you can also try this here. This will be the more recommended way, right? You can say counter the class name .g, right? So that one there, if you try to execute this line here, let me call it number 5. Counter.g is just referring to counter.g right here, incremented. So it's going to be from 2 to 3. So that will be number 5. Okay. So try to look at this code very carefully on the paper and also try them out on the Eclipse to really understand how the non-static versus static will work. Okay? Yeah, question.
If it's global, do you have to fix the or can you just call the method?
The global, you mean here?
No, number 3.
Number 3 here?
Yeah, do you have to fix the or can you just call it?
Yeah, so increment local here, you can see that method there is just like a regular non-static method. So in order to call a method, you have to give a context objects. In this case, that's why we're going to, so you can think about, in order for you to change the global variable, which is G here, you can either do it through C1 or through C2. The effect will just be the same. You're just modifying the same global copy here. Yeah. Yeah.
So for slide number 75, so what will you do for ID?
Yeah, we'll get there. We'll get there. Yeah. All right, guys, so that's about static versus non-static. So let's now revisit the account class very quickly. All right? I got about 3 minutes. Let's see what we can do. So we'll definitely talk about how things can be done properly, and then we'll talk about maybe some common errors, maybe on Thursday. Just spend a little bit of time. Okay? So now notice the following. We got static integer. We got integer, right? So think about what we got is, let's see here. We got static integer, that's going to be global. And also we got some integer ID, that's local. Right? Right here. So we got these two. And notice one thing here. Once we got this static variable help, we don't need that extra parameter anymore, right? Notice that, right? Compare this version here with the previous version where we got some explicit parameter for the account. Right? That's the difference. Okay? Let me write this down very quickly. Okay? For this one here, you want to think about the owner here is the only parameter. So the list of parameters does not include, not including the ID anymore. That means anybody who's using your account constructor, they don't have the burden to actually pass some unique ID explicitly. That's not their burden anymore. Not burden of user of the account constructor anymore. Okay, let me just trace the code very quickly, right? And then that'll be it, about 2 minutes, okay? Bear with me. Let's now talk about how we can do that, right? We got only 2 objects over here, right? Before that, let's set aside the global variable here, global counter 1. So what I would do is I'm gonna set this global counter here, right here, okay? A single copy. So think about this is going to be a global, only a single place counter. And then global, I'll say GC. GC, I'll put a star here. That means it's not like a non-static attribute, it's not. Initial value will just be 1. Only a single copy, right? Just keep that in mind. And then we're going to create 2 different objects. Object number 1, ACC1. How do we do that? So ACC1 is going to point to some account object over here. And then, so that one there is going to be account. And every account has ID and owner. So we don't include GC, right? We don't do that, okay? So we got the ID and also we got the owner. All right, here comes a very important point. Here, this.id, so this right here is ACC1. ACC1.id is going to be the global counter value 1, right? And then after that, we're going to increment the global counter from 1 to 2. And then the owner is going to be just Jin, string value. Follow? Okay, let's do one more line. And the next line here, ACC2, right here, right? Second objects. So what we do is we're going to ACC2 pointing to a new account object right here. Also, we have ID and the owner. ID and also owner. So we're going to execute the constructor for the second time, right? So now this right now is going to be ACC2. So now it's ACC2. ACC2.id is going to be global counter, which is right now 2, right? So it's going to be 2 right here. Notice that 1 and 2, automatic. And then global counter, got to make sure it's actually set for the third object being created later. So that one there is actually going to be incremented from 2 to 3. And then we set owner to be also Jeremy. Okay? And then if you say ACC1 again ID, now equal to ACC2ID, of course 1 and 2 are different. So what we have done here is we really don't need to pass any explicit value as a parameter for a constructor because we're using static behind the scene. This example code here is only provided on the slides. I would encourage you to try it out by maybe incorporating it into your lab 0 or just create a new classes yourself, right? Give it a try. All right, thank you. And then on Thursday, we're going to look at common issues for static variables.